That's all. Today I am going to present the real number system and its properties in a different way. I think all of you know what is the real number and how it is constructed. Okay, you know the usual convention of the number system starts from the natural numbers. Then we can extend it to whole numbers, next integers, rationals, then irrational, again into real numbers. But here I am going to express the real number system in a different way. First I state the properties of real number system, and from that properties we show that the real number system contains natural numbers, next integers, rationals and irrationals, etc. Okay, in earlier classes we are studying in the opposite side. Okay, the first we start with natural numbers, then goes to real numbers. Here first we state the properties of real numbers. From that we show that it includes naturals, integers, rational numbers, etc. Okay, the properties we can classify it into three. First, algebraic properties of real numbers. First is algebraic properties, and the second order properties of real numbers, and the third the completeness property, or another name supremum property. First I state what are the algebraic properties. Okay, you know, I think in the set of real numbers there are two binary operations. First we denote by plus and second by dot. Okay, first is the called addition and dot we call it multiplication. Now what is a binary operation? Binary operation. Addition is a binary operation in real numbers. Okay, what is mean by a binary operation? Consider any two real numbers A and B. Then A plus B is again a real number. Okay, that is true for all real numbers A and B. So addition is a binary operation. If you operate any two elements of that set, if the result is again in that set, then the operation is called what? A binary operation. Similarly, multiplication is also a binary operation. These two operations satisfy 9 properties. They are called algebraic properties of R. The properties are, first, the 4 properties based on addition. So we can denote it A1, A2, A3 and A4. A1 is, the addition is commutative. That is, A plus B is equal to B plus A for all A comma B element of R. Okay, I think you know the commutative property. In the real number system, the addition is commutative. Next, consider any 3 real numbers A, B, C. Then as we know, A plus B plus C is equal to A plus B plus C. That is, the addition is associative. Okay, so these are the first two properties: addition, commutative. Second, addition is associative. Next, in R, there exists an element which we denote by 0. There exists an element called the 0 element having the property A plus 0 equal to A for all A element of R. Okay, this is called the additive identity. Okay, 0 is called an additive identity. Next, corresponding to every real number A, we can find a minus A. We call the negative of A having the property A plus minus A equal to 0. These are the 4 algebraic properties relating to addition. Next, we state the algebraic properties relating to multiplication. There are also 4: M1, M2, M3 and M4. M1 property is, for any 2 real numbers, A dot B is equal to B dot A. Meaning, multiplication is also commutative. Just like addition, the second operation is also commutative. Next, multiplication is also associative. That means A dot B dot C equal to A dot B dot C for ABC element of R. Okay, next. There exists an element which is denoted by the symbol 1 in R having the property for every A in R, A dot A equal to A. This one is called the multiplicative. Next, corresponding to every non-zero real number. Here we stated that there exists an element 0. Okay, if A is not equal to 0, we can define an 1 by E. It's called the multiplicative inverse of A. That means for every non-zero real number, there is a multiplicative inverse having the property A dot 1 by A equal to. These are the 4 algebraic properties relating to multiplication. Now there is a 9th property combining addition and multiplication. Okay, it is called the distributive property. So I denote by. What is distributive property? A dot B plus C is equal to A dot B plus A plus C. These 9 properties are called the algebraic properties of R. Okay, why it is called algebraic properties? Okay. The reason is every properties, algebraic properties can be derived from these 9 basic properties. Just like Euclidean geometry. Have you heard of Euclidean geometry? In Euclidean geometry, Euclid first stated 5 basic axioms. Okay. Here also these 9 are axioms. Okay. By using this, we can find all the algebraic structures. Okay. Next, consider this property. For every A, the element 0 is there. What is A plus 0? It is equal to A. First, we show that this 0 element is unique. Okay. This is called A0 element. Okay. A0 element. If we prove that this 0 element is unique, we can call it the 0 element. Okay, in real number system, there exists only one 0 element. Okay, to prove the uniqueness, we consider a set. We consider first a real number set. Suppose Z has the property like this. For every A in R, Z plus A equal to A. Okay, what's the property of Z? For every A in R, that is a fixed element, Z plus A equal to A. Okay, if we show that this set equal to 0, we can say that the 0 element is unique. Okay, if we prove that if Z satisfies this property, then this set is equal to 0, there exists only one 0 element. So from this we can prove that Z equal to, the proof is like this. Consider Z can be written as, we have only the 9 algebraic properties. By using that, we can derive all the other things. Okay, so first consider Z. Z I can write it as Z plus 0. Okay, Z can be written as Z plus 0. Why? The property of 0 element. Okay, plus 0 equal to what? Next, instead of 0, I write A plus minus. Instead of 0, I write what? A plus minus A. Because there is again the fourth property. For every A there is a minus A and A plus minus A equal to 0. So instead of 0, I write Z plus A plus minus. Next, again I use associative property of addition. Z plus A plus minus A can be written as Z plus A plus minus A by using the associative property of addition. Now what is Z plus A? It is given that Z plus A equal to A. So Z plus A equal to A. So finally we get A plus minus A. What is A plus minus A? It is again equal to 0. So I prove that Z plus A, if Z plus A equal to A, then Z equal to 0. That shows that the 0 element is unique. There exists only one element in R. We call it 0 having the property. So this shows the uniqueness of the 0 element. Similarly, we can prove that the identity element, okay, or the unit element of multiplication, which we denote by 1, is also Okay, consider the statement. Suppose u is any real number. you having the property that any u dot b equal to b. What is b? It is a non-zero real number. Then if we show that u equal to 1, we can say that the unit element is also a. Okay, what is the property of unit element? For every a in R, a dot a equal to a. If I prove u dot b equal to b, okay, then if u equal to 1, we can say that the unit element is also a. Okay, now consider the given statement, u dot b equal to, we have to prove that u equal to 1. First I start from u can be written as u dot 1. You can be written as u dot 1. Now instead of 1, okay, I write b dot 1 by b. Given that b not equal to 0. If b not equal to 0, there exists 1 by b having the property b dot 1 by b equal to 1. So instead of 1, I write b dot 1 by b. Then this there are three elements u, b and 1 by b. Here I use again the associative property of multiplication. This can be written as u dot b into 1 by b. What is u dot b? It is given that u dot b equal to b. So finally b dot 1 by b. What is b dot 1 by b? What is b dot 1 by b? 1. So we have proved that b equal to 1. These two results shows that the zero element and the unit element are equal. Okay, so these are already algebraic properties of R. Totally 9 algebraic properties. Okay, next we can define addition and subtraction and division by using the algebraic properties and the two properties addition and multiplication. In R, subtraction is defined as subtraction is denoted by this a minus b if a and b are any two real numbers. A minus b is defined as a plus. Okay, so by using addition, we can do the subtraction operation also. Basically, in R, there are two operations: addition and multiplication. Subtraction is we can convert it into addition. Similarly, suppose a and b are two real numbers and b not equal to 0. Then a by b is defined as a into 1 by b. If b is non-zero, 1 by b is a real, there is 1 by b. So a by b is defined as a dot 1 by b. Okay, so totally we have defined 4 operations in R. Next, you look at the problem 2x plus 3 equal to 4. Suppose we want to solve this problem. We can use the algebraic property to solve the problem. You know the solution. Okay, in our class we have studied, just take 3 to here, then divide it by 2. But actually they are all algebraic operations. To solve it, first we have to eliminate 3 from here. Okay, for that we just add minus 3 on both sides. Okay, then we get 2x plus 3 plus minus 3 is equal to 4 plus minus 3. 4 plus minus 3. By using the associative property, this can be written as 2x plus 3 plus minus 3. Okay, this is equal to 4 plus minus 3. 4 plus minus 3. Next, what is 3 plus minus 3? 0. Okay, so here 2x plus 0. What is 2x plus 0? It is equal to 2x. It is equal to 2x. Next, we know in R there exists the unit element, one element of R. By using this one and the operation of addition and multiplication, we can show that R contains the set of natural numbers. Okay, R contains what? The natural number. How can we define natural numbers? By using 1 only. Take 1 plus 1. We know 1 is in R and addition is there, so we can define 1 plus 1. We denote 1 plus 1 by 2. We denote 1 plus 1 by 2. Next, 1 plus 1 plus 1. We denote this by what? 3. Similarly, we can define n by how? By the n-fold sum of 1. So by using 1, we can define all natural numbers. Okay. Okay, so we have to do that. Natural numbers is a subset of what? Similarly, we can show that integers is also a subset of R. R contains integers also. Okay, how can we define integers? How can we define integers? We know one is in R. We know one is in R. If one is in R, minus one is also an element of R. Okay, if one is in R, minus one is also in R. Then minus one element of R and a element of R imply minus one into a element of R. Okay, by using natural numbers and this minus one, we can show that it is also a subset of R. Okay, that is also a subset of R. Next, by using the operation of division, we can also show that rational numbers is also a subset of R. So by using the algebraic properties, we can show that R contains what? Natural numbers, R contains integers, and R contains rational numbers. Next later, we will prove that R contains what? Rational numbers also. Okay, here the problem is 2x plus 0, that is what? 2x. Next, what is 4 plus minus 3? What is 4? The fourfold sum of 1. What is 4? 1 4 times. What is minus 3? Minus 1 3 times. Okay, 1 plus minus 1 is equal to 0. By using that, we get 1 plus minus 3 equal to what? Minus 1. Next, what is 2? 2 is minus, okay, 3. 4 plus minus 3 what? 1. Next, what about 2? 2 is a non-zero real number. Okay, 2 non-zero means there exists what? 1 by 2. So I multiply both sides by 1 by 2. 1 by 2 into 2x is equal to 1 by 2 into 1. Next, 1 by 2 into 2x can be replaced. 1 by 2 into 2x equal to 1 by 2 into 1 is 1 by 2. What is 1 by 2 into 2? 1. Next, 1 into x is 1 by 2. That gives x is equal to 1 by 2. This is the actual idea behind okay. Okay. So that means x plus 3 equal to 4 gives x is equal to 1. We have proved it by using our algebraic properties. Okay. So the first property of R is algebraic properties. Algebraic properties total 9 properties are the first 4 properties. Addition properties. Next 4 multiplication. The last is distributive property. Next, I define the order properties of in R. We can consider a subset which I denote by P. Okay, we can consider a subset P. P is called the set of positive real numbers. Okay, the set of what? Positive real numbers. Okay, now we have the property that if A element of P, B element of P, then A plus B element of P. Okay, A plus B element of P is the first property of P. That shows that sum of two positive real numbers is again a positive real number. Next, A and B element of P. A and B element of P implies A into B also element of P. These are the two basic properties of P. What is P? The set of what? Positive real numbers. Then if A and B are in P, then A plus B element of P. A and B are in P, there will be also element of P. Next, third property. If A is a real number, then either A equal to element of P, or A equal to 0, or minus A element of P. Just think of it. Suppose you take a real number, then that property shows that either A is in P. That means either A is a positive number, or A is 1, 0, or minus A is again in P. That means if you take any real number, it either belongs to the positive set, okay, or it belongs to what? 0 set, or it belongs to the negative real number. Minus A element of P is a negative real number. Okay, this property divides the total real numbers into 3. Hence, this property is called the trichotomy property, the law of trichotomy. That property divides the entire real number system into 3. First, positive real number. Second, 0 alone. Third, negative real number. Okay, next. If A and B are any two real numbers and A minus B element of P, then we can say that A greater than B. Okay, if A minus B element of P, we can say that A greater than B. Next, if A minus B element of B union set to 0, then we can say that A greater than or equal to B. By using these two properties, we can compare any two real numbers. Suppose we are given two real numbers, for example, A and B. We are given two real numbers, A and B. If A and B are given, we can find A minus B. Okay, if A minus B is element of B, A minus B is a real number means A minus B has three choices. Okay, either it belongs to P, or A minus B equal to 0, or minus A minus B element of P. Either real number has this. Okay, if A is a real number, then either A belongs to B, or A equal to 0, or minus A belongs to B. Here, A minus B is a real number. So, A minus B either belongs to B, or A minus B is 0, or minus B belongs to P. If A minus B belongs to P, by using this definition, we can conclude that A greater than B. If A minus B equal to 0, by using algebraic properties, we can prove that A equal to B. If minus A minus B element of B, meaning by opening this, we can write it as minus A plus B element of P, or E minus A element of P, or that is B greater than B. That means we can compare any two real numbers. We are given two real numbers. We justify A minus B. If A minus B is positive, we can say that what? A greater than B. If A minus B is 0, we can say that A equal to B. If A minus B minus A minus B is positive, we can say that A less than B. That means we can compare any two real numbers. Okay. I think you know what is complex numbers. Okay, in the set of complex numbers, this type of properties are ordered. There is no order property in the set of complex numbers. Suppose you are given two complex numbers, can you compare it? Can you say which is greater? No. Okay, but real numbers have property. So you can say that R is a ordered set. But R is a ordered set. The algebraic property says that if any set satisfies such 9 properties, we can say that it is a free. We can say that it is a free. It means there is a set and two binary operations. Addition, one is denoted by addition, second is denoted by multiplication, and they satisfy the 9 easy properties. Then such any set is called a free. So comparing these two properties, we can say that R is a what? Ordered field. Okay, prove that R is what? The set of real numbers is an ordered field. Okay. So first multiply properties, second order properties. Okay, prove that R has multiply properties and order properties. Now, any doubt?